Hi everyone, this is Vaitheeswar from Chennai, and this is about the review of Boston house price prediction, which I done a project in a Skyfi Lab. Here, our aim to develop a machine learning model using linear regression to predict the monetary value to the house. And here I have used a dataset. It's Boston house price dataset, and the steps involved to solving the problem or first step is a data pre-processing, and the second is a define an error, and the third is to split the data into two parts. And here we split the data into the two parts. The first one is a training data and the second one is a testing data, and the fourth is a train the model. Here I have used learning the target functions given by using the machine learning algorithm problem and train it on the data, test the model with the testing data, and at last fifth step is a prediction to obtain the predicted value for the given input and visualize the result. And here before that we have imported some libraries. Here I have used import numpy as np and a pandas as pd and the matplotlib as mpl and matplotlib as .pyplot as plot. From matplotlib animation, import function animation to use a visualization, and more I have used Skylearn datasets to import the load Boston and a mean square error and the training test split and a mini max scaler. And at last I have used the ipython.display from import to HTML text. And the first thing, data pre-processing. We need to load the data into our we have taken from the Boston to load the Boston by using the Skylearn sklearn datasets. From the dataset I have loaded, and here is my dataset characteristics. Here you could see 506 instance, and the attributes are 13 attributes in a numeric, and a 14th attribute is a median value. And here you could see CRIM, and it's a per the abbreviations are per capita crime rate by town. Likewise, and after that put the data into the panda data frame. We use a feature, and this feature will be able to see what are the data frames and how the data frames could be moved into this. Here we have used a panda.data frame, and we have imported the load the Boston data along with the columns to the Boston feature names and the features you could see. At last we need to get the target, and the target of after that we need to concatenate the features on a target into a single data frame. So by using this we could see about the crime, resource and index. Likewise, using the describe to generate the summary of the data set. Here you can use to df to describe to round off the decimals. And after that you could see the correlations is a statistical technique to use. And moving forward, you could use the correlations to get the absolute correlation at a target from into the list. We have used a list comprehension using this topic. And after that we need to make a list of pair using the core and a feature. And here I have used a list zip function into the course on a list of features. And after that we need to sort the list by using this key. And once we unzip the pair of a two list, we could see that the course label and the list zip L. We could see the correlators has been here and the labels are listed below. And now we need to plot the correlation with respect to the target variable as a bar diagram. By using the plot plt.x label and plt.y label, I can easily mention that the correlation with the target variable which is present in the y label and the attributes has been present in the x label. And to plot plt.show, you can see the bar graph, and here you could see the L stat is having nearby to the 0.7 of the correlation, and chaos is it's less than to the 0.2. And we have observed the bar graph generated above the L stat and RM have the two highest absolute correlation values. Now we need to normalize the data. To normalize the data with a minimax scaler, we can use this. And x is equal to df of L stat values, and along with the target we need to print it. And this is before the normalization. And once we split the data into the fixed set, here the data has been split and we use the three functions to constitute the model are error, update, and a gradient descent. The error, this function returns to mean squared error in the predicted value for a given m and a c. And update, this function changes the value of m and a c. And gradient descent, this function implements gradient descent. And we have used some parameters to change to vary to observe compulsion versus accuracy trait, and the parameters we have used is the learning rate, iterations, and the error values, error threshold, and initial values. Now first we need to define an error. So here use a function error m x c t, and after that we need sum along with that, and we need to update the function. Once we update, we can use grade of m is equal to summation of 2 into m into x plus c into t of into x. And here we could see a gradient descent function. Here I have used a init m values. The parameters here I have used a init m, init c, x, t, learning rate, iteration, error, threshold. And once all this has been initiated, all the values has passed those to the gradient descent function. You could see the wall time and how much it has been taken over. You could see these values, a gradient descent. Now we need to print the m and c. So the mean is it's here and the constraint is there. And after that, this is about the mean square error, how the noise has been get cancelled and how the noise has been driven. And before we see about the normalization of the value what you've seen before, and this is about the value what we see after a normalization. And the visualization to the learning, we have 2 points: plot to the regression line against the training data to visualize what the line look to the training data set, and the second one is a plot the error value. This graph shows how the error drops over time. Now we have to see the first one, the plot the regression line upon to the training data set. We use a scatter, plt.scatter to use the scatter points, and we use a plt.plot to train that. And plotting the error, we have seen the error and iterations and how many iterations we seen. We need to, and here you see the error is 0.5 and it's been started at the 0.5 to the iteration of the 50, and once it's crossed to the 50 to the 100 250 iterations, the error value is being decreased to 0.01% error. And here I use an animation, and this is about the 5th step in the prediction. And once we got all the data has been into the vectorized operations, we use the predicted value, and here you could see the mean squared error by using the y-test and a predicted value. And after that, put the x-test and y-test predicted values into the single data frame so that we can see the predicted value alongside with the testing data. The p.data frame list zip x test and y test and the predicted value columns. You can see this in the way. And how to plot a predicted value against the target value, we can use the same thing where we used before. It's a plt.scatter to see the scatter point and plt.plot to see the plotting test. Here for the scatters we use a blue dot, and in the plot we have used the line which is showcased, which is in the inverse way in the red color. And this is about the reshape, and once we reshape the change the size, the shape that required to the scalar, and this is to remove the extra dimension. Once we done that, we could see about what is the target of the target and a predictor, and this is about to predict the Boston house prediction. Here we could see an interesting part. We have gone through that the LSTAT is the leading one, and if we observe that the bar graph is generated LSTAT, RM, and it's so on to DISC. So what if I change to see the normalized value here by changing it into the RM? here I have changed into RM values. So once I got the RM values,